This is the history of human weather modification. During World War II, too many British Air Force pilots were crashing while trying to land in heavy fog so thick, some crews just ditched their planes in the sea and parachuted out rather than landing blind. So scientists came up with a plan to install gasoline pipelines along both sides of the runway and ignite them to create huge rows of flame, which then evaporated suspended fog droplets, allowing the Allied aircraft to locate the airfield and land safely. In 1946, techniques were developed that triggered rain and snowfall in places that wouldn't have gotten any otherwise. This became known as cloud seeding. It works by dispersing dry ice, salt, or silver iodide into clouds to alter their microphysical processes. In the early 60s, the US government began testing cloud seeding on hurricanes to learn if it was possible to weaken them. Rocket canisters of silver iodide were dropped from aircraft into the storm's eye, and gun-like devices mounted on the wings also sprayed the stuff onto the clouds. Initially, the tests seemed to work. Wind speeds were cut, and in some cases, the hurricane eye walls even fell apart. But as observational technology improved and more controls were carried out, the hypothesis was invalidated and the program was canceled. In its desperation to win the Vietnam War, the Americans turned to weather modification to make it harder for the enemy to move throughout the region by inducing heavy rainfall to muddy or destroy their dirt roads and trails. 47,000 canisters of silver iodide were dropped over North and South Vietnam, Cambodia, and Laos. Some areas supposedly saw their monsoon period extended by up to 45 days, but just 2 days after the New York Times exposed the program, it was discontinued. Operation Popeye caused the USSR and US to negotiate a ban on the military use of offensive weather modification techniques in 1977. But the treaty didn't stop countries from using cloud seeding against themselves, as the Soviet Union did in 1986 when the Chernobyl nuclear disaster sent fallout into the sky. Civilians on the ground and the Russian pilots who carried out the mission have confirmed that aircraft flew overhead, ejecting a substance into the clouds. This resulted in heavy, black-colored radioactive rain to fall in Belarus instead of onto the Soviet capital, Moscow. Today, 37 countries are operating weather modification programs to enhance rainfall or suppress hail, or both. But nobody does it quite like the Chinese, who established the Bureau of Weather Modification in the 1980s that's now a 37,000 people strong sort of weather national guard, ready at a moment's notice to operate the more than 4,000 rocket launchers, 7,000 anti-aircraft guns, and 30 aircraft to trigger downpours in drier areas that really need the rain. The Bureau's highest profile operation was keeping Beijing's Bird's Nest Stadium dry during the opening ceremony of the 2008 Olympics. The following year, the Bureau dropped 186 doses of silver iodide into a cold front to bring drought-stricken Beijing its earliest snowfall since 1987. A Swiss company took advantage of the United Arab Emirates' desperation to bring rain to its arid lands by building 10-meter-tall electrical towers that produce negatively charged ions that, according to the company, supercharges the formation of rain clouds. But a former chairman at NOAA isn't buying it, saying, quote, "This method is inherently incapable of producing clouds out of thin air," end quote. The thing about weather modification is that it's hard to prove it works. But based on the results we've seen and the number of countries still doing it, man's effort to control precipitation isn't stopping anytime soon, even though we have little understanding of the unintended consequences.
In trying to predict these capricious changes in weather, we sometimes resort to rather questionable weather forecasting devices, such as an almanac, a crystal ball, a gouty leg, and the law of average. This is the master control room. Electronic maps and view screens display up-to-the-minute pictures of the weather around the Earth. Every hour, reports are automatically received from all points at sea, on land, and in the air. 22,000 miles out in space, 3 robot satellites train their sensitive television eyes on all parts of the Earth. These pictures are monitored on viewing screens in the Weather Center. Here in the computing room, electronic machines digest the constant flood of information received from all stations. This is then translated into an ever-changing diagram of the Earth's weather. Forecasts for every sector of the globe are made months in advance. Prediction charts have indicated that a powerful hurricane will begin forming today in the Atlantic Ocean. The electronic weather map shows an intense storm system building up about 1,000 miles due east of Miami, Florida. The controller calls for a close-up satellite view of the troubled area.
Coordinates. Coco 526, Yankee 2.5.
Okay, controller. Coco 526, Yankee 2.5.
The characteristic swirling clouds of the hurricane are beginning to form. At sea, the waves anticipate the violence to come. The controller calls for a last-minute prediction of the hurricane's path. If control measures are not begun at once, the hurricane will smash across densely populated areas within 48 hours.
11 a.m. EST. A hurricane is forming 960 miles east of Miami, Florida. If control measures are ineffective, it will pass inland at Cape Hatteras in 48 hours. Control operations will begin within 2 hours, but safety precautions should be completed from Cape Fear, north no later than 6 p.m. tomorrow.
At Weather Central, the control strategy is mapped out. A ridge of high pressure slants across the eastern United States between two low-pressure storm systems. If these two storm centers are intensified, the high will build up along the coast, forming a barrier that will turn the hurricane out to sea.
Stand by. Now pulling in satellite number 1 for visual check of low-pressure systems L20 and L21.
The operator brings the satellite into focus on the two storms. One centered over Kansas, the other over Labrador.
Changing the northeastern low, L21.
With the touch of a button, the battle begins. On the ground, chemical cloud seeders begin to work the two storm areas. Robot planes seed the clouds from above. The storm centers over Kansas and over Labrador intensify as seeding continues.
Now changing over to Hurricane Center H8.
The fury of the hurricane mounts as 100-mile-an-hour winds lash the sea to a foaming frenzy.
All stations, Sector C. Activate Phase 2, Control Plan Delta. Set vapor rockets for 42,000 feet. Execute.
As an emergency measure, the controller calls for a salvo of vapor rockets to be fired ahead of the path the hurricane is predicted to take. These artificial clouds will block the sun from evaporating more water to feed the hurricane. The reports coming into the control center indicate that the diversionary cloud seeding over Kansas is now creating a flood danger. Specially equipped robot aircraft are dispatched immediately to release a high concentration of cloud seeding material into the fringes of the storm. Heavier seeding from the ground also helps to subdue the rain by spreading it over a wider area. The controller calls for another view of the hurricane, which has now moved closer to the coast.
Signal out on number 1 satellite. 10-minute interruption for correction. Have you anything else in the area?
Satellite station S1 is approaching area. We'll make contact. S1, this is Weather Central. Request video signal at grid coordinates Coco.
An emergency situation has developed. In an orbiting space station 1,000 miles above the hurricane, a crewman sends a temporary picture back to Weather Central.
Okay, S1, your video is R5S5. Thank you.
The hurricane has stopped moving toward the coast, but is still intensifying. It must be made to move northward and out to sea. This is a crisis.
Aberdeen Station. Activate multiple seeding rockets on course 117.
The controller decides to fire cloud seeding rockets just ahead of the hurricane, hoping to start it moving. Slowly, the hurricane begins to shift. All available forces have been brought into play. Now we can only watch and wait. After hours of tension, the turning point is reached. Latest reports indicate the control strategy is successful. At last, the high-pressure ridge has settled along the coast, forming an invisible wall of safety. The storm is over. The danger has passed. The hurricane has been defeated, turned away from the land, and left to spend itself harmlessly far out at sea. In the world of tomorrow, weather control will enrich and safeguard our daily lives. In the foreseeable future, we will conquer more than violent storms. We will turn the destructive elements of today into new sources of power, shaping the land on which we live. All mankind will benefit. Arid wastelands will be made green and fertile, and vast frozen areas will become productive. To this end, man-made satellites will probe the secrets of the skies. They will be our eyes in outer space.
talk about controlling the weather. You may have noticed higher temperatures, stronger storms, and more abnormal weather events becoming less and less abnormal lately. Well, maybe the idea of actually controlling the weather starting to seem like a pretty useful option to have in our toolbox. But the big question is controlling the weather actually even possible? And if so, how could it be done? Well, let's get into it. The idea of controlling the weather sounds kind of like an evil plan hatched by a James Bond villain, but it's closer to reality than you might think. Here's a true story that once made headlines, but today it's not very well remembered. In the 60s, war was raging in Vietnam, and the US military thought, this isn't going our way. Maybe we should try something a little more unconventional, which usually doesn't end well. Their bright idea was to start a clandestine operation to extend the monsoon season in Vietnam by releasing silver and lead iodide into an existing storm. By making more rain, the goal was to increase flooding and thereby disrupt troop movement and the deliveries of supplies to the North Vietnamese. The enemy would be destabilized and the US would win the war. So, make mud, not war was even an unofficial catchphrase used by the pilots on these cloud seeding missions. These missions were dubbed Operation Popeye. I don't know why, I haven't found a good explanation, but there you go. They went on for 5 years before the public found out about them and the cloud seeding stopped. While there's no confirmation that these missions had any real effect, we can confirm what was happening in the skies based on atmospheric science and previous lab experiments. Basically, water vapor condenses around particles in the atmosphere. These are called cloud condensation nuclei. They're the beginnings of every cloud droplet. You can think of these little nuclei as like seeds from which fully developed raindrops originate. Silver iodide particles have a similar structure to these initial ice nuclei seeds, which allows water droplets to condense around them, freeze, and then fall as either rain or snow depending on the air temperature. Adding more and more of these seeds into clouds basically helps bring the precipitation faster than it would come naturally, or so we think. Now I hope the term cloud seeding makes a little more sense. In an ideal scenario, more cloud seeds equals more rain, which was the goal for Operation Popeye. Still can't get over that name, it's so weird. The US isn't the only country to dabble in weather modification, but it's not always used for nefarious purposes. See, after Operation Popeye, weather modification was actually banned from being used in warfare, but it's still allowed when it comes to peaceful purposes. In 2020, the United Arab Emirates faced deadly heat waves, and to counter the arid climate, they ran about 200 cloud seeding operations in the first 6 months of the year to bring more rain into the region. Canada has used cloud seeding to limit the intensity of hailstorms, and China has enthusiastically embraced cloud seeding, putting billions into the technology. They've used it for everything from reducing air pollution in Beijing to even improving weather conditions ahead of big events like the 2008 Olympics. It would make sense to think that changing the weather on this large scale requires a lot of starter particles, but sometimes that's just not how it works. Most of the time, cloud seeding doesn't even require that much silver iodide to nudge a storm to do its thing. 1 gram of the stuff can create around 10 trillion artificial ice crystals. So typically, cloud seeding operations only release small quantities of the particles. That sounds almost like anybody could do it, but it's not that simple. First, silver iodide is pretty toxic stuff. You'd want to handle it with care. There's also an important caveat to understand as well when it comes to cloud seeding, and that is, no one is entirely sure how effective the practice actually is. If Joe Schmo wanted to release silver iodide into clouds over his next-door neighbor's house because the neighbor had a barbecue and didn't invite Mr. Schmo, Schmo wouldn't definitively know how much his rain DIY seeding operation actually caused rain to fall and ruin his neighbor's day. But I can see why the neighbor didn't invite him if he's willing to go to those extremes. In other words, once a cloud is seeded, scientists don't have a good way of figuring out how much more rain or snow would have fallen compared to how much actually would have fallen naturally if the cloud was just left alone. So a quick refresher. For precipitation to occur, there needs to be clouds already in the sky. These clouds would have likely deposited rain or snow or hail anyway. It gets even more complicated because those atmospheric conditions happen once and only once exactly that way. How often do you know Mother Nature to play out the same scenario a second time on command just because it would be useful for gathering data? So because it's impossible to replicate atmospheric conditions in a natural setting, it gets really hard to prove definitively how effective cloud seeding is outside of lab experiments. Even during Operation Popeye, there were reports that the missions were successful, but no one collected any data from Vietnam to really back up that claim. Fast forward to today, and there's still a lot of uncertainty when it comes to cloud seeding's effectiveness. I've seen some reports suggest it can bring anywhere between 10 to 15% additional precipitation if conditions are right, but I've also seen studies suggesting a negligible difference. Now, I'm not here to poo-poo cloud seeding. Without a doubt, something is happening as a result, but it can get pretty murky, and the history of weather modification has also been home to its fair share of charlatans. There's something called the hail cannon. It basically looks like a blunderbuss someone would use to shoot Zeus, and some farmers today swear by it. But there's no hard evidence that backs up its effectiveness. There were salesmen during the 19th and 20th centuries who would travel through areas impacted by drought, and they would convince people who were desperate enough to pay them that they could bring the rain. I'm not joking when I say that one of these guys even called himself the Moisture Accelerator, which is a gross nickname. You gotta wonder, is that his only job with a name like that? Don't think about it too much. Now, we've talked a lot about using cloud seeding to increase precipitation, but is there a way to stop it? Like, if someone were to accidentally seed just too many clouds and make it rain too much? Well, we actually can use Operation Popeye as an example. Between 1967 and 1972, the US military ran over 2,000 cloud seeding missions, and it probably won't come as a surprise to you that every now and again they missed their target. In an interview with the New York Times, one official once said, "We used to go out flying around and looking for a certain cloud formation, and we made a lot of mistakes." One of those mistakes was pummeling a US military camp with about 18 centimeters of rain over the course of 2 hours. Another mistake was reported in a memo between a couple of officials, which said, quote, "In one instance, the rainfall continued as the cloud moved eastward across the Vietnam border and inundated a US Special Forces camp with 9 inches of rain in 4 hours." Unquote. It's a lot of rain in a short amount of time. So, as you can see, once the storm gets going, there's not a lot that can be done to stop it. But that hasn't kept people from taking this idea even further. See, when the first cloud seeding experiments were performed in the 40s, people were convinced that our advancing science had the power to control the planet's thermometer. It was supposed to herald a new era when we could take a scalpel to the skies. If we wanted rain, we would get a downpour. And if we wanted a sunny, beautiful day, well, by golly, we'd have clear skies. If a hurricane was heading towards a populated area, we could divert the storm like Hercules diverting the rivers. But making it rain, so to speak, that's peanuts compared to controlling something as large and powerful as an entire hurricane. If we want to figure out how to stop a hurricane, it helps to know how they begin. First, you get 2 adult hurricanes that love each other very much. And wait, no, that's something else. Oh, I remember. Okay, so typically, hurricanes start out over water when the surface temperature reaches at least 27 degrees Celsius. Warm ocean air starts to rise and low pressure areas move in. With this low pressure comes wind, which pushes in more warm air, and the warm air continues to rise until it cools off and forms clouds and storms. So one idea would be to cool the sea surface temperature before it reaches that 27-degree threshold. This idea is called marine cloud brightening, and it uses cloud seeding as a way to increase the number of droplets in a cloud, making them whiter and more reflective to sunlight. A couple of scientists have proposed sending a fleet of autonomous ships to the Atlantic Ocean before hurricane season begins, where they would mill around seeding clouds with cool salt water. That way, by the time the next hurricane season comes around, ocean currents have cooled to the point where mega hurricanes just can't form anymore. There's also an idea to increase bubbles on the water's surface. It's kind of the same concept. It would whiten the water and reflect more sunlight. There's even more wild ideas like nuking hurricanes, but those are far-fetched and dangerous to say the least. We'll likely see things like this keep popping up again and again, though, as we continue to experience more megastorms as the climate warms. I probably don't need to mention it, but I will. The vast majority of climate scientists believe that our climate is warming, and it's probably going to lead to more frequent and more severe storms in the future. Which might make you wonder, if the future we're facing looks like that, maybe it makes more sense to alter the entire climate rather than just individual storms. Will we have more success if we go down that route? Well, messing with the Earth's natural systems to combat climate change is called geoengineering. Cloud seeding is a technique of geoengineering, but it's often used to describe changing single weather events. What some people want to do is completely alter the climate over the long term, not just on a case-by-case basis. There's one such technique that's been proposed, and it's been getting more attention in recent years. It's called solar geoengineering. Essentially, this type of intervention means limiting the amount of sunlight that reaches the Earth's surface. There's a project at Harvard called SCOPEX, and it's proposing to do just that. The team behind the project plans to launch a balloon up into the atmosphere where it will release around 100 grams of calcium carbonate. It's a common ingredient in antacids. And they would measure things like atmospheric chemistry and how well light scatters off of these particles. And the results would help determine if the project was a success and how maybe it could be scaled up. Now, this project is still in the experimental phase, and it needs more review before getting off the ground. No pun intended. However, if everything works out, years down the road, we might be seeing this project or something like it releasing particles into the atmosphere. So sunlight would reflect back and the planet would cool down, theoretically.
State lawmakers believe some aircraft are dumping chemicals in the sky to try to manipulate the weather.
While a federal weather agency says it's doing no such thing, a bill is making its way through the legislature aimed at ending so-called chemtrails. Andres Fuentes reports.
Ponchatoula State Representative Kimberly Landry Coates defended a Senate bill aimed at a problem she says is growing across the state.
Your bill would prohibit the intentional release of dispersion of these chemicals that you're talking about. And you said it's to control the weather? Is that what you said?
Yes, ma'am.
Coates says the bill prevents the white straight lines in the sky left behind by aircrafts. The Environmental Protection Agency says jet aircraft do form what's called contrails under certain atmospheric conditions, like when a jet's heat meets the cold atmosphere. It's the same reason that we can see our breath on a cold day. But Coates and other lawmakers call the lines chemtrails. She claims the lines are made of nanochemicals that change the weather.
Other than the nanoparticles of aluminum, what else have you found?
Barium, and there's some long words that I can't pronounce.
On the House floor, Coates claimed that the National Oceanic and Atmospheric Administration sends chemicals into clouds to reflect sunlight in an effort to make the Earth's surface cooler. NOAA says it does not conduct weather modification experiments and has no plans to do so. Coates also believes other agencies are involved in the so-called chemtrail conspiracy theory across Louisiana.
Who is doing this?
There's multiple people, multiple groups, contractors.
Who are the contracts with?
I've seen the documents with at least 9 federal agencies.
We reached out to Coates for clarification on her claims, but have not heard back. One of those claims is that she sees the lines in the sky regularly.
Once a week?
At least, yes. From my house all the way to the Capitol. So when you look up in the air, you watch for the big white lines across the sky.
And so I just need to look up. I probably haven't been looking up.
Lawmakers were mixed with the vote, passing the measure out of the House despite some Republicans joining the Democrats in voting down the bill. Now that measure will head before the state Senate lawmakers sometime next week.
While France puts the clouds up, America knocks them down. This is the Cloudbuster Squadron of the American Air Force. For the last 3 years, using their giant C-130 plane, they've been punching holes in clouds.
133, you are cleared for The Cloudbusters, originally a military project, are led by Colonel James Church. Their operations are first sounding the cloud, then seeding the hole, and then slow-motion photography of the result. It's when they see the light in a cloud known as a glory that they swing into action.
Okay, this will be a four-strip seeding pattern at 180 knots. We ready to start seeding our rear? Roger, sir, all ready. 5, 4, 3, 2, 1. Start seeding strip 1. Roger, rotating, sir.
A big cloud can weigh 100,000 tons. The pellets the cloudbusters use to soak up the cloud weigh half an ounce each. The squadron makes 4 runs in a cross shape to get their effect.
All right, in 5 seconds we will start seeding fourth and last strip. 4, 3, 2, 1. Start seeding fourth strip. Roger, we're seeding, sir. How's the machine running? Excellent, sir. Couldn't be better. Cutting nice clean pellets? Roger. We will end seeding fourth strip in 5 seconds.
The phenomenon called an undersun, a sure sign that the cloudbuster has worked. Within 45 minutes of seeding, holes as big as 100 square miles, large enough to clear most of London, have been punched in the cloud cover. It's all on the Air Force inventory. Anyone can order the cloudbuster service.
Those were some of the efforts at bending the weather. But ironically, aircraft may be changing the weather by accident.
For example, we have thousands of jet airplanes flying through the air every day, and they're pouring exhaust gases into the atmosphere. There's some evidence that these exhaust gases may cause increased amounts of cirrus cover. If this is so, and it seems very likely, we may be changing the heat balance of the Earth enough to actually be producing inadvertently weather modification on a scale that we don't even have any way to measure at the present time.
The fuels we burn have already caused a rise of 10% in the carbon dioxide in the air. In the future, this could produce a considerable rise in temperatures around the Earth.
Apart from local alterations, what are the chances of changing whole regions of engineering on a global scale?
So you've either got to do it by brute force, which means that to do something really, really big.
Extraordinary crimes against the people and the state must be avenged by agents extraordinary.
Time and place for everything.
Quite. If we still have an enemy.
Now is the winter of your discontent. The weather is no longer in God's hands, but in mine. Hundreds of millions will die. They'll drown, burn, freeze. And this is merely the beginning. Let our revels begin.
After tea.
Of course. John Steve.
You'll pay for that.
Did you know the U.S. military once tried to control the weather as a weapon of war? That's right. In the thick of the Vietnam War, a classified operation was set into motion. Codenamed Operation Popeye, it was a project unlike any other in the annals of military history. Its objective? To manipulate the weather itself. Imagine this: a military force that could command the clouds to pour down rain at its whim. The U.S. military aimed to do just that, targeting specific areas of Vietnam. The reason? To disrupt the enemy's supply routes, to turn the very elements against them. This was a time when the boundaries of warfare were strained, pushed, and sometimes even shattered. Operation Popeye, shrouded in secrecy, was a testament to this new era of conflict. It was a venture into the uncharted territories of weaponized weather. Intriguing, isn't it? The thought of manipulating the weather as a tool of warfare. So, how did this audacious idea come to life? Well, it all began with a proposal by Jack Anderson, a man with an inventive mind and a belief in the power of weather as a weapon. He saw the potential of manipulating the weather to disrupt enemy supply lines and operations. In 1966, the idea was put to the test. Under the watchful eyes of the 54th Weather Reconnaissance Squadron, the powers that be initiated a testing phase. This period was primarily utilized to assess the feasibility of using weather manipulation as a strategic tool in warfare. After the trial showed promise, the operation officially kicked off in 1967. The 54th Squadron, the unsung heroes of this clandestine operation, were tasked with carrying out the mission. Their goal? To seed the clouds over the Ho Chi Minh Trail, creating torrential rain and turning the enemy's main supply route into a quagmire. And thus, Operation Popeye was set into motion, a weather manipulation program unlike any other. Now let's delve into how Operation Popeye was actually executed. Operation Popeye was a marvel of scientific ingenuity and military strategy. At its core, it involved manipulating the weather to gain an upper hand in the Vietnam War. The primary method used was cloud seeding, a process where substances like silver iodide were dispersed into the air to stimulate rainfall. The basic idea was that by boosting the amount of precipitation, the U.S. military could turn the Ho Chi Minh Trail, a key supply route for the enemy, into a muddy, impassable mess. The operation was concentrated on the eastern and southeastern areas of Laos, where the Ho Chi Minh Trail snaked its way through the dense jungles. The goal was simple: flood the trail, disrupt the enemy's supply lines, and bog down their movements. The U.S. military hoped that monsoon-like conditions would create enough chaos to give them a strategic advantage. And it wasn't a small-scale endeavor by any stretch of the imagination. Over the course of 5 years, from 1967 to 1972, the operation saw a staggering 2,600 flights. Each flight dispatched a cargo of cloud-seeding agents into the atmosphere, seeking to turn the skies into a weapon of war. But despite the scale, Operation Popeye was shrouded in secrecy. The U.S. military didn't want the world to know they were dabbling in weather warfare, a practice that raised many ethical questions. The mission was so clandestine that even those involved in the operation were given limited information about its true nature. Nonetheless, the operation ran its course. The skies over the Ho Chi Minh Trail opened up, unleashing torrents of rain on the jungles below. But did it truly give the U.S. the upper hand they sought? That's a question still hotly debated among historians and military strategists. For 5 years, Operation Popeye sought to drown the enemy's strategies, quite literally. But every action has its consequences. What were the ramifications of Operation Popeye? In the early 70s, a cloud of controversy began to form over Operation Popeye. The covert operation was disclosed to the public in 1971, sparking widespread debate and outrage. The revelation that the United States military had been manipulating the weather as a tool of war raised significant ethical questions. This was no ordinary military strategy, after all. This was the force of nature, harnessed and repurposed for warfare. The rain, once just a symbol of life's ebb and flow, had been weaponized. And this weaponization didn't just raise eyebrows, it raised serious concerns about the potential for future misuse of such power. The controversy surrounding Operation Popeye did not merely dissipate like the clouds it had sought to create. Instead, it led to concrete action. In 1977, the world came together to pass the Environmental Modification Convention. This international treaty explicitly banned the use of weather manipulation for hostile purposes. With the stroke of a pen, the world made it clear the weather was off limits for warfare. The skies could no longer be weaponized. The power of the storm could no longer be harnessed for destruction. This was a significant step forward in the ethics of warfare, a step prompted by the fallout of Operation Popeye. Yet despite the ban, the legacy of Operation Popeye cannot be easily erased. The operation stands as a testament to the lengths that warfare can push the limits of innovation. It's a stark reminder of the fine line between innovation and ethical transgression, a line that we must be ever vigilant not to cross. Operation Popeye remains a stark reminder of the lengths to which warfare can push the boundaries of ethics and innovation.
What if you could fire a laser at the sky and make it rain? Oh, that sounds more interesting. Dave Malkoff explains.
Just another stormy, wet afternoon in Central Florida. But what if you could pick up all this rain and move it where it's needed? Texas or California? What if a laser could start the rain?
So you can almost use it to set it off.
Matt Mills got into lasers as a kid.
It's just innately cool.
Now he's part of a team of scientists and military backers on the cutting edge of a new technology, making lasers powerful enough to reach up here into the sky where a thunderstorm is just about to start. In the near future, a push-button storm starter could be a real thing.
Just imagining this situation. If there was a rain cloud that was going to pass over an area of drought and not rain, you could, theoretically induce the rain and get the rain where it's needed.
That storm starter isn't the laser beam itself, but rather a popping energy that comes off of much higher power beams than this one. The problem is those pops have always had trouble getting into the sky. Now Matt has discovered a way to get the laser to pop all the way in the clouds. In theory, that's what starts a storm. We created a cloud of our own behind Matt's lab. A few months ago, Matt's colleagues in Arizona got this working experimentally. The next step is to get it to work in the sky.
The particles in the air are rubbing together, forming static electricity, and the conditions are now right, and they just need to be triggered now.
Does this concern you that you may be messing with Mother Nature and doing something that you don't completely understand up here in the cloud?
I suppose that's always a danger, but we're not even near to the case where it could be dangerous yet, so not too much now.
It's almost like an on-off switch for a thunderstorm.
That's the idea behind it.
Right here in the cloud.
Yep.
In Orlando, Dave Malkoff, the Weather Channel.
Absolutely fascinating. Absolutely fascinating. And it could change a lot of things, like these areas of drought that we're watching in the West, if it actually worked. All right, let's move on to sports.
That was amazing. I saw those lasers at a cabaret in Tampa. It made it rain there, too.
There was a period, actually more than a couple of decades, when the U.S. government was actually convinced that they might be able to tame nature's vortex. The ambitious Project Storm Fury deserves to be remembered. The idea of humanity manipulating the weather is not exactly new. The Smithsonian's Science History Institute notes, for example, the ideas of pioneering meteorologist James Pollard Espy, whose convection theory of storms revolutionized meteorology and resulted in his appointment as the first meteorologist for the United States government, a position for which he laid the basis for scientific weather forecasting. But Espy's ideas went beyond predicting weather. Rather, he argued that he could eliminate droughts, heat waves, and cold snaps, keep the rivers navigable, and render the air healthy by clearing it regularly of noxious vapors. His method? He suggested setting fire to the forest of the Appalachian Mountains, and thus causing heat updraft that would drive thunderstorms. He suggested setting such fires weekly, preferred Sunday evenings. Smithsonian notes, dryly, although Espy was justifiably celebrated for his convective theory, his reputation was tarnished by the ridicule his rain-making proposal received. His was not, perhaps, the most dramatic proposal. In the 1880s, flamboyant patent attorney Robert St. George Dyrenforth, a Civil War veteran whom the Lancaster, Pennsylvania intelligencer said had received wounds in nearly every part of his body, theorized that explosions in the atmosphere could cause rain. In 1891, he used his theory on the United States Capitol. The intelligencer writes, "About dawn one morning, the Capitol was awakened by a mighty series of explosions in the vicinity of White Lot. The detonations were terrific and in rapid succession. The populace scurried to the doorways, apprehensive that the warships of some foreign power had slipped through overnight up the Potomac." Now, you might imagine that the colonel would receive some sort of punishment for feigning an attack on the nation's seat of power, but instead, Smithsonian writes, Dyrenforth, with a grant from the U.S. Department of Agriculture, took a team of artillerists to Texas to attack the atmosphere on multiple fronts. With dynamite and blasting powder, mortar shells, smoke bombs, electrified kites, exploding oxyhydrogen balloons, and even fireworks. The results were questionable, although the colonel took credit for every rainstorm in the vicinity, and henceforth the eccentric colonel was called Rainmaker, but the experiments didn't continue. These were but a few attempts, as Professor James Roger Fleming of Maine's Colby College noted on the Smithsonian website. Over the past 2 centuries, dreams of weather and climate control have produced a series of ill-considered and ill-fated interventions aimed at what at the time seemed to be the most pressing issues of the day, from health and farming in the 1830s, western drought in the 1890s, and fog and aviation in the 1920s, to Cold War attempts to use weather as a weapon, and onto current heroic responses to global warming. But of all the attempts to control weather, one has a particular imperative and has been the focus of experimentation: the attempt to control one of nature's most destructive forces. The science website How Stuff Works explains, it depends on how you measure it, but by any way you slice it, hurricanes release a phenomenal amount of energy. The website measures the energy generated by wind, as well as the energy that generates the clouds and rain. In their calculation, a typical hurricane will generate and release upon the environment the equivalent of 10,000 nuclear bombs. And we're just talking about average hurricanes here, are they right? Not Katrina. According to the National Oceanic and Atmospheric Administration, since 1980, hurricanes have caused over $1.3 trillion in damage and have been responsible for the deaths of 6,890 people. But as early as the 1940s, researchers began to consider a radical idea. Could we impact the strength of a hurricane? NOAA's Hurricane Research Division explained in the Bulletin of the American Meteorological Society, since a hurricane's destructive potential increases rapidly as its maximum wind becomes stronger, a reduction as small as 10% would have been worthwhile. The idea began with the introduction of the still used and still controversial practice of cloud seeding. We all know that water freezes at 32 degrees Fahrenheit or 0 degrees Celsius. But that is not strictly true, as the science website Skybrary explains. The freezing point of water is 0 degrees Celsius, but it might be more accurate to say that the melting point of ice is 0 degrees Celsius. This is because, for a number of complex reasons, water exists in liquid form well below 0 degrees Celsius. Water that remains liquid below the common freezing point is called supercooled water, and it turns out supercooled water is quite common in certain types of clouds. The website Phys.org explains supercooled liquids are trapped in a metastable state even well below the freezing point, which can only be achieved in liquids that do not contain seeds that may trigger crystallization. Clouds at high altitude are a good example for this. They contain tiny droplets of water that, in the absence of seed crystals, do not form ice despite the low temperatures. That is to say, the water is so pure in clouds that it lacks impurities like dust around which the water crystallizes. The website of NASA's Earth Observatory explains supercooling may sound exotic, but it occurs pretty routinely in Earth's atmosphere. Altocumulus clouds, a common type of mid-altitude cloud, are mostly composed of water droplets supercooled to a temperature of about minus 15 degrees Celsius. Altocumulus clouds with supercooled tops cover about 8% of Earth's surface at any given time. There is, however, a limit. At minus 40 degrees, coincidentally the mathematical point where the Fahrenheit and Celsius scales converge, supercooled droplets will quickly freeze. As NASA explains, air temperatures over jet wings often cool by as much as 20 degrees Celsius, pushing supercooled water droplets to the point of freezing. This is what causes the aerodynamic contrails behind aircraft. The supercooled water in clouds might have been cool, but it wasn't really super cool in terms of meteorology until 1946, when Dr. Vincent Schaefer, working in a General Electric laboratory, made an accidental discovery. The University of Arizona Water Research Center writes that Dr. Schaefer was doing research on a hot summer day and cold temperatures were required. He was using a chest-type deep freezer, and he decided to lower the temperature further by placing a chunk of dry ice into the deep freeze. He noticed an unexpected reaction. While working over the open freezer, his breath had created a small cloud of supercooled water droplets. These droplets appeared as a sort of haze in the freezer when light was shown through them. Introducing dry ice caused the water droplets to freeze due to the very cold temperatures of the dry ice. They froze, forming tiny ice crystals that scintillated in the light. The university notes that the classic experiment is easily replicated. What is most important, however, is the implication. The university website continues. Dr. Schaefer's serendipitous discovery demonstrated that supercooled cloud water droplets, common in clouds, could be artificially induced to freeze. And science began to theorize. If supercooled water and clouds could be so induced, would those clouds then release their moisture? Could scientists produce rain? And as the water was supercooled because it lacked seeds upon which to crystallize, this new idea became called cloud seeding. Something that Schaefer initially attempted by flying through supercooled clouds in a plane equipped to drop dry ice particles, much like what had happened in his freezer. The idea of cloud seeding gained enough traction that in 1947 the government contracted with General Electric on an ambitious program to test the process, Project Cirrus. Meg Marquardt of Mississippi State University explained on the science website Earth. Together with GE, the various branches of the government and military formed a coalition headed by GE scientist and Nobel laureate Irving Langmuir, called Project Cirrus, which was to investigate the possibilities of cloud seeding, an early form of geoengineering for a host of potential uses like producing rain in arid regions. But the project soon went after more than rain. Marquardt continues. If an injection of dry ice could disrupt the structure of the storm, the project scientists reasoned, then perhaps the hurricane would dissipate. Right after World War II, science could do anything, says Hugh Willoughby, an atmospheric scientist at Florida International University in Miami. No one had thought through what would happen if you seeded a hurricane. They didn't know about the cloud structure in a hurricane. It was just kind of, let's do it. To be safe, the project leaders decided to test their theory on an Atlantic hurricane that was predicted to wander harmlessly out to sea, away from land. NOAA explains that the opportunity arrived in 1948. It wasn't until late in the following hurricane season that Air Force planes and Navy personnel became available to carry out the mission. On October 12th, a hurricane, designated King by the Air Force Hurricane Office, moved northeastward over Florida, dumping tropical downpours on the southern end, which caused damaging flooding that persisted for days. But the next day, the storm moved off the coast and continued out to sea. King offered an opportunity for Project Cirrus. NOAA continues. This seemed an ideal case for Project Cirrus, as the hurricane was no longer interacting with land and should not affect anyone after the experiment. And so in 1948, the United States Air Force attacked Hurricane King with the same weapons that it had used to defeat Hitler and Tojo, namely one B-29 and two B-17 bombers. NOAA writes that large chunks of dry ice were fed into a crusher on the first B-17 and dumped from the belly into the clouds below. The second B-17 followed a half-mile behind and 3,000 feet above to document the cloud changes, and the trailing B-29 was the control aircraft and carried Schaefer to monitor the changes and direct the other two planes. The results were noted, but not spectacular. They first made a half-hour run over 100 miles long, dumping 80 pounds of ice along the way. They backtracked then to see what the clouds had done. Next, they did two mass droppings of 50 pounds, each into one large cumulus top, and orbited the cloud to see any changes. They noticed that after the first run, the cloud deck below began to break up. After the second test, the cloud top continued to grow. Satisfied with their effort, the airplanes returned to base. But then, disaster struck. NOAA writes, the scientists were eager to examine the storm the following day. However, when they flew to the predicted storm location, they had trouble locating the eye. And after some hunting around, they found that the hurricane center was nearly 100 miles west of where they expected it to be. To their astonishment, the hurricane had made a 135-degree left turn and was now moving due west. And on top of that, it was strengthening. That is, after seeding the storm, it suddenly turned, got stronger, and headed for land. NOAA writes, by the afternoon of the 15th, Hurricane King struck Savannah, Georgia. One person died in the storm surge, and $2 million in damage was done to Georgia and South Carolina. Whether the storm was affected by the 180 pounds of dry ice wasn't clear and certainly not proven, but NOAA writes the public's enthusiasm for weather modification slackened. In an era when many science fiction movies featured mad scientists threatening world destruction or worse from their hubris, this event seemed to fit the trope. For many years after, no scientist dared mention weather modification and hurricane in the same sentence. The Hurricane Research Division said simply, embarrassment at the time left a legacy that had an adverse effect upon political and legal arrangements for later hurricane modification efforts. But like a hurricane, the idea of hurricane modification did not easily dissipate. Further destructive hurricanes, as well as the desire to better predict the storms, would give rise to a new project. By 1961, enough had been learned about hurricanes to produce a workable theory. The Hurricane Research Division of the National Oceanic and Atmospheric Administration explains. The working hypothesis was that the area around the eye wall of a hurricane was either inertially unstable or nearly so, and that the clouds there contained abundant supercooled water. Thus, seeding near the eye wall could trigger inertial instability and cause outward migration of the eye wall, leading to reduction in the maximum wind through conservation of angular momentum. The website of Charlotte's Spectrum News 1 explains the larger eye wall would help reduce the storm's winds by reducing the pressure gradient of the system. The hope was to do this before a system made landfall to reduce the potential damage of the storm. Rather than use dry ice, in 1948 another GE researcher named Bernard Vonnegut determined that silver iodide smokes, which are more similar to ice crystals, were more effective at seeding than dry ice. The idea was first tested using Weather Bureau planes on Hurricane Esther in 1961. NOAA explains that the Bureau kept things on the down low until they were sure that the storm wasn't going to pull a swerve on them. The results showed promise. After the seeding, the storm stopped deepening, and this success was enough to take another step. The Hurricane Research Division writes, the encouraging results from Hurricane Esther led to formal establishment of Storm Fury, a joint project of the United States Navy and the Department of Commerce in 1962. To avoid the 1948 disaster, Marquardt writes, all seeding with Storm Fury was carried out only if a storm met a long list of criteria, including a less than 10% chance of hitting land within a day of seeding, even if the storm made a sudden turn like the October 13th hurricane. The criteria proved daunting, and between 1963 and 1971, Operation Storm Fury only successfully seeded 4 hurricanes. While there was no disaster like what happened with Hurricane King, there was a close call. In 1965, project directors chose Hurricane Betsy as a good target. However, historian Carl Whipple explained in his 1982 book Storms, Betsy turned the wrong direction. Swerving from northwest to west, the storm seemed to be taking a dead aim for the Bahamas. Storm Fury officials decided that they could not risk seeding, and they canceled the effort. But in an oversight the project overseers would have reason to rue, someone forgot to notify all the press, and a few newspapers reported that the cloud seeding was actually underway. Betsy missed the Bahamas, but careened into Florida, causing 81 fatalities and more than $1 billion in damage. Whipple writes, the repercussions this time stirred the ire of Congress. It took 2 months for Storm Fury officials to convince Congress that cloud seeding was blameless for Betsy's abrupt change of course. And in perhaps the strangest criticism, the Salt Lake City Weekly reported, the project raised the ire of Fidel Castro, who accused the United States of trying essentially to weaponize the weather. Admittedly, there's something a bit Strangelovian in the image of Navy fighter bombers dumping chemical canisters into a hurricane. Couple that with an amped-up name like Storm Fury, and it all seemed a little nuts. The last attempt of Operation Storm Fury was Hurricane Ginger in 1971. While there initially seemed some promising results, NOAA notes that further research found that the positive results inferred from the seeding experiments in the 1960s stemmed from inability to discriminate between the expected results of human intervention and the natural behavior of hurricanes. Finally, in 1983, more than a decade after the last attempt to seed a hurricane, the project was canceled. The Hurricane Research Division writes, by mid-1983, none of the conditions for development of an operational hurricane amelioration strategy could be met, and Project Storm Fury ended. The conclusion? The hypothesis was flawed. The Hurricane Research Division writes that Storm Fury had 2 fatal flaws. It was neither microphysically nor statistically feasible. First, research finally showed that hurricanes have too little supercooled water and too much natural ice for seeding to have any notable effect on them. Meanwhile, the effects of seeding are often indistinguishable from the natural intensity changes of hurricanes. Project Storm Fury wasn't entirely a bust, in that the project helped to learn quite a lot about how hurricanes operate and to improve the equipment and instruments that are used to measure and track them. But it was wholly unsuccessful in the goal of having weather cowboys corral unruly hurricanes. Seems no matter how hard we try, nature still wins.